Let's take a look at Chapter 6 review. Now when you read these problems, first thing you got to determine if it's binomial or Poisson. And basically your guideline is going to be, if it says Poisson somewhere in your problem, then it's a Poisson distribution. Otherwise you can assume binomial. Number one here, assume the male and female births are equally likely and the birth of any child does not affect the probability of the gender of any other children. Find the probability of exactly 9 girls in 10 births. Well, we need to find n first. 10 births. So right here, this implies that n is 10. Now we need a little p, and this is the probability of getting a girl in one birth. Well, if they're equally likely, then that would be 1/2 or 0.5. And then what they're wanting us to find is probably exactly 9. So do x equals 9. Well, this, we plug it into Excel, will be equals binom distribution, and then this first one is going to be 9. Number of trials was 10. Probability was 0.5. Cumulative would be 0 for no, since we're doing exactly 9. Let's take a look at number 2. Assuming that male and female births are equally likely, birth does not blah 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 blah. Nowhere does it say Poisson, which means it's binomial. So we need n, and I think it's 10 again. Yeah, 10, and p would still be 0.5, and they're wanting us to find at most 3 girls. At most 3 means it includes 3, so we're going to have x is less than or equal to 3. Now remember, in order to plug it into the binomial, you have to be going from 0 up to the number, which this one is, because that's x equals 0, 1, 2, and 3. So we're going to do binom dist, and then 3, number of trials is 10, probability is 0.5, and cumulative would be 1, because we're adding up all the probabilities from 0 up to that number. Number 3, recent survey, well, blah 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 blah. I'm scanning through looking for Poisson. I don't see the word Poisson anywhere, so I can assume it's binomial. I'm not going to be tricky on this. I'm not going to throw a Poisson on there without it actually telling you it's a Poisson distribution. A recent survey found that 70% of all adults, usually when they give you a percent, that's going to be your p. Let's see, in a random sample of 10 adults over 50, so it would be 10. And p would be 0.70. Sometimes they give you the opposite. See, they say 70% wear sunglasses. Down below they might ask how many don't wear sunglasses, but these match. They say at least 6 wear sunglasses, and up here 70% is talking about the ones that wear sunglasses. So at least 6. At least 6 would mean greater than or equal to 6. Now let's think what this means. That's x equals 6, 7, 8, 9, and 10. But we can't put that in the calculator that way, so we'll do 1 minus probability of x equals 0 to 5. Remember, for the binom distribution to work, you have to go from 0 up to a number. And 1 is everything. That would be 0 to 10. If I cross off 0 through 5, that'll leave me 6 through 10. So this would be binom distribution, 1 minus, sorry, 1 minus binom distribution, and then 5, and the number of trials 10, probability was 0.7, cumulative would be 1. Problem 4. Again, we're going to scan it through looking for the word Poisson. We believe that 87% of all population of the Calc 1 students, blah 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 blah. Nowhere to see Poisson, so I'm assume binomial. 87% consider it to be an exciting subject. Probably 87% can be our little p. Suppose we randomly and independently selected 25 students, so that's n. And the true percentage is really 87%, so they're telling us little p is 87%. Find a probability of observing 24 or more. So 24 or more would be x equals greater than 24, which doesn't work well because it has to be from 0 up to a number, plug in the calculator. So I do 1 minus probability of x equals 0 to 23. 1 is everything. If I cross off 1 through 23, that'll leave me 24 and 25, which is what I'm looking for. Let me do it actually right up here. Because 1 minus binom dist, number of trials would be 23, and then total would be 25, 0.87, and 1 for cumulative. Problem number 5. Blah, 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 blah. Use a Poisson distribution. So we're changing now. We're not doing a binomial. This actually says Poisson. History gives an average of 3 students arrive. Probably in a randomly selected office hour and 10:30 time slot, exactly 5 students will arrive. So my mean is 5. And we're trying to find exactly 5. So x equals 5. This will be equals Poisson. And then x would be 5. Our mean was 5 also. And then cumulative would be 0 since we're doing exactly a value. Customer service firm receives an average of 3 calls per hour on its toll-free number. For any given hour, find probability will receive at least 3 calls. Average of 3. So my mean is 3. And we're looking at probability to receive at least 3 calls. It means x is greater than or equal to 3. Now what that means is probability that x is equal to 3, 4, 5, on forever. So we have to do 1 minus probability of x equals 0, 1, 2. Because again, to put it into Excel, that should be x equals. There we go. To put it in Excel, it has to go from 0 up to a number. We can't do 3 up to a number. There we go. So putting this in, we're going to have equals 1 minus Poisson, and then our mean, which is 3. The ending number, we're going from 0 up to a number, so 2, and cumulative would be 1. Okay. Local animal rescue organization receives an average of 0.55 rescue per hour. Uses a Poisson distribution to find a probability during a randomly selected hour the organization will receive fewer than 2 calls. Well, again, it's Poisson. I didn't say it, but I saw the Poisson. And we're looking for, see, fewer than 2. Fewer than 2. That means x is less than 2, which would mean x equals 0 and 1. So to put that into our into Excel, we'll do Poisson, and then 1. The ending number, we're going from 0 up to a number, comma our mean, which the mean was 0.55, and comma 1 for cumulative. Make sure I put these in the right order. Okay, mean. I don't think I did that right. Let me see here. Yeah, this one's looking for the ending number when we're going from 0 up to a number, which would be 2. Then our mean is next. I thought I had that backwards. Then 1. Let me check this one out. Well, that one's 5, 5. But, again, it'll guide you when you're doing this, and you type it in, equals Poisson. When you do the beginning parentheses, it tells you what to put in next. X, then your mean, and then the cumulative. So that really is handy. I just didn't read on that one. Now, that's going to be the review for the Chapter 6 material, and that's how you tell what do you use. Use binomial, do you use Poisson, or what exactly?